for this. Okay. So when you log into DolphinNext, usually I always come to run status and see what kind of runs there. And if there are errors, we go and check what might be the error. So some people created their own pipelines. See, like this is not ours. Somebody else has created this. Or our basic tutorial. This is also belonged to someone else. So, okay, so what we are doing. So when you go to pipelines, there is a link here to start creating a new pipeline. Or there's another link here to start creating a new process. So what I want to do, I just want to press this just to show you again this pipeline screen. So here there are a couple tabs. The first tab is about the description. So you can write a summary about this workflow. So for example, this is my first workflow. And so when you press this, it's going to save it. When you want to edit, you're going to edit like this. So, and there is also a workflow section that we will create a workflow here. And there's an advanced section here if you are creating more advanced stuff, like, you know, creating a Docker file to run this anywhere, not only our cluster, you need to create a Docker file, or you can define different number of CPUs per process, for example, in the future. So there are many details that you can work on. And also if some pipelines support headers and footers. So, but you don't need to do those things. These are more advanced. And the thing that you might need to do in the future to share your pipeline with other people. So if you are working in a group, you can create a group in your profile. If you go to your profile section, so you're going to see a groups tab, and you can create a new group. And then when you create your group, you can share your pipeline with your only my group, and then choose your group or everyone to share with everybody. So these are good functionalities to share what you're doing with other people. So when you're creating a workflow, the first thing you need to do is searching a process. For example, if you want to do a bow tie alignment, you can just search bow tie, build index, and build index bow tie, check build. You can look at these by clicking these processes like I did, and look what they're doing. So for example, this thing is checking some parameters. You can ask us too, we can explain what we are doing here, but basically it's just running bow tie using a genome index. Genome index is coming as an input. So if you like this pipeline, then what you can do, you can just drag and drop and start using it like this. You can just put this, which one was that? For example, check bow tie build. So you can just put and use it like this. Or you're not happy with any of the processes you searched, what you can do, you can just create your own process like this, like new process. When you click here, basically you're just gonna write a name. For example, I want to run fastqc. And you can write a description here, my fastqc process. And this is going to belong to you because I haven't shared with anybody. So this is going to be mine. And you can put the menu group. You can add a new menu group to yourself, or you can choose like QC, for example, menu group. And then you can input will be the FastQ files. So in the bootcamp, if you follow the instructions here, that inputs, like for example, reads FastQ, like this section will be my input, like written here. And the name that we're going to define, we're going to use this val name and file reads in the script section. So I'm just going to copy this. It's not here. Let me search. Okay, here reads. It's going to be set. Yes, FastQ set. So there are a couple things that you can see, like for example, read pairs FASTQ read. I want to use exactly the same thing. This one reads FASTQ. And this is going to be while name file reads. This might look weird to you, but the reason we are doing this to support paired and files there and get the name from the read name. So it's just removing this r1.fastq section from the reads and giving you only the name, and then the output will be better. That Onur was talking about this last week. So I'm gonna get this, and do we have another? No, we don't have it. You can put mate too, but you don't need it for this, for FastQC, because when you put the files next to FastQC like this, it's going to run it for all the reads you have in your FastQC, for your FastQ files. So, and the output will be the HTML. Like, I'm just gonna copy this and output file HTML. If this is not here, so if the things you're working are not in this box as input and output parameters, there is this section, parameter section, you can create yourself, like plus, write the identifier and file type. Or if you choose a value just to get a mate or like anything, you want to define any name, you can actually write it here and use it there. Any questions about this, inputs and outputs? Okay, good. I'm just going over like real fast just to show you what we are doing. So now we are ready. So we get the inputs. So we just simplified all Nextflow workflows like this. So you have your inputs, you have your outputs, and you have your scripts. So when you think like this, inputs, outputs, and script, then you can actually create more modularized pipelines by putting like very small commands into these sections, but you can use the same thing in other pipelines. So we are gonna write this FastQC reads, $reads. And this is going to be shell. See, now this is ready. That's all. When you save, it is gonna go to my QC, FastQC, this is mine. I just created this one. See, I put this and I have my input, I have my output, and the script is here. If you click here, you can go back and then improve this process. And when you improve, when you add more stuff here, like for example, ls $reads, for example, just to show you what's happening. By the way, I can save this changes on top of this because I haven't used this. But in the future, when I use this once, and when I run this pipeline once, it is not going to allow me to write on top of like this. It is going to ask me, are you going to, do you want to create a new revision? And then you can actually track what you did before. And okay, FastQC is ready. And I'm just gonna show you one more, like HiSet2 process, for example, a second one. And then I'll connect them, and I'll talk a couple more things. And I'm not going to create all of them, or I'm not going to create HiSet2. It's the same. I'm going to use other people's HiSet2, another module, HiSet2, for example, this one. It should be the same. Okay, reads. This is not the same. No, it's the same. Sorry. See, HiSet2 reads, index, and map reads as an output, BAM file, and text file as a summary. So these were the 2 lines that you're running. So you learn some tools, view and stuff. HiSet2, you could do star too, because you learned star too, but HiSet2 is very similar. You have your index file, your reads, and the output will be SEM. There are some parameters you're using. And when you put the output into this file, you can get an alignment summary, like how many reads map to the genome plus transcriptome. So here, when you do this, so when I'm adding an input here now, like how I'm doing, so you need to add an input and then give a name for this input. For example, this name will be my reads. Okay. And when I connect this with my reads, see, now this has a value in it. Now this reads, this input, when I connect, when I connect this, the type of this input will be FASTQ files. Now there is only FASTQ sections that I can actually send my reads again. See, this is the only place that I can send. See, I cannot connect with this node here. I have to use this one. Now when I connect, so when you are creating your pipeline like this, so this can send the reads to both processes at the same time. So they're gonna start parallel. So you can create a parallelization like this. But so if I connect other process after HiSet2, for example, to convert output file to something else, for example, or to merge BAM files coming from different processes, for example, then if I connect this with something else, it's not going to start until this process finish while running. Okay, so this is going to be another input that I'm going to put, and this is going to be HiSet2 index, for example, HiSet2 index. And now I'm going to put my output parameters. So this is going to be my, for example, it is FastQC and FastQC out, and publish to web directory. So you can publish this as an HTML, for example, or if it's something else, you can choose from here. If it is PDF file, you can choose PDF reader. And here, map reads will be BAM files. I'm not going to publish to the web because they take a lot of space. Usually we don't have enough space to cover BAM files, but just talk with us. If you need to publish BAM files to web directory, we can create a special directory for you. You can do that. We need to talk about it for big files. So here, this is a small file. This is HTML, nothing. It's very small. So I'm going to put another output here and this is going to be my summary. I said summary, for example, and the publish directory will be text, because I know this is going to be text. So now I think that's enough, but this is, you can create as many things as this and then connect them and create your pipeline. So when you save this, I'm going to save this as my HiSet pipeline. And I save this and I will put into a menu here. So maybe test menu, and it's saving now. So it's gonna go here to my test menu. Where's that? My HiSet pipeline. See, it's here. So when I click, I can come to the same pipeline. See my first workflow, advanced, share with everybody or not. So now I think this is ready to run. So when I do this, create a new run. So I'm gonna put this into my test project. You can create a new project. And then when you press this button, select project, and you're gonna write a new name, HiSet run, for example. Save run. See, I created like a pipeline in a couple minutes, and now it's ready. So you need to see the form came now here automatically. I just put two inputs. One is reads, the other one is HiSet2 index. But the first thing you need to do is to just choose the environment. And And so this is the work directory you need to enter. We were talking with Melvis, like you need to write your project space, for example, project vmw test, and I'm gonna write test high set, for example. So, and then reads. So you can add some of your reads. You learn add reads from geo and CVI, for example, or some of the reads you can search paired and single end. So there's one thing that I was going to show you when you're running. So what was the directory here for the reads while running? Okay. This is the image pad cluster. Okay. Input reads. Is it here? I think this, oh, this is single one. Okay. So see, you can write a directory like this, or maybe I'm going to do this. I just want to show you something. So genome data, for example, you don't know exactly where they were. You just, when you press this button, so the list is coming here. It's kind of hidden feature we have here, but you can go and go to, for example, mouse test. I'm here. Now when I click, it's going to go inside. It's like, maybe you haven't realized this, but you can find it like this too. So for example, I don't know, one of the, maybe DolphinNext. Okay, there are a couple of files here. So these are FASTQ, and I'm going to make it single list. Any questions? Could you please mute?
Alper, could you make us a co-host so we can mute people?
Okay, sorry. Yeah, you're right. Where was it? Okay, I'm going to do it in a second. So let me finish. Okay. I'm almost done. So here, I selected my files. I'm going to add a couple of them. Add selected files. See, when I add like this is going to merge these controls into a single file. This is important. But if you don't want to merge them to create a single file, don't do this because they're going to be processed together, and it's going to use a new name called control, for example. You can change this name too. But if you add like this, add all files, or you can add one by one, add selected like this. And
I have a quick question. Does the analysis differ if you process them together as one file or as separate files? Will the output give you different results?
For example, if you want to do a differential expression analysis, you don't want to merge them and do the analysis like this because you need biological replicas and need to quantify them separately. So this is just merging and quantify together. So you're not using that information coming from different biological replicas when you are doing your analysis. So for example, in the browser section, or today, at the end of today, I think we're going to do a couple of plots. You're going to see how we are using biological replicas. But in some projects, you don't need biological replica information. You just need to pile them up into a single BAM file and then use them like that. It might be possible. That's why we give this flexibility here to merge the files. Or sometimes you do sequencing twice on the same samples. They are called technical replicas. Then if they are technical, you need to merge them and process with the same as a same sample. So here, but in this case, I'm just gonna put like this, for example, 1 and 2, whatever. I just put this, and you need to write a name here, my test samples, and then press this add, or just press somewhere else, and then save files. And these are the files you're gonna select, or you can still remove some of them and select, and add more later when you come here. So now my test samples are there. So if you want to see what you had before, just click here. And there are details section. You can always go back here and see where the file is located and what's the file name. So in GHPCC server, for example. So you have all that information here. Sometimes you back up your reads to Amazon. You can go here and see if you back them up to Amazon S3 backup or Google storage, or sometimes what you do, you merge technical replicas into a single file. You're going to see multiple input files here, and local archive directory is going to be here. So there'll be a single file in that local archive directory. Then in the future, you don't need to merge them again and again. You can choose that single file from your local archive while running in the future. So if the file is there and merged, DolphinNext is checking if there is a file in local archive directory and processed, already merged, then it's not trying to merge again in the future. So it's doing that operation and checking, and if it's there, it's using that file. Okay, so, and then HiSet2 index, when you enter that file, oops, where is it here? For example, this was the HiSet2 index file. See, the other thing that you're going to see, until I enter all the value, all the necessary values, not everything here, but all the values here, it's going to be waiting. See, it's not going to allow you to run if this parameter not entered, because this is required parameter. So you just need to add this as a value manually here, genome, and then save. It's there now. So now you can run this, but the other thing that HiSet2, when you go to, so if you understand this important features, then your production will be faster. So when I go to cluster, this is my cluster. When I try to run fastqc, for example, see command not found. But in my workflow here, when I was doing the workflow, when I was writing it, so I just choose fastqc command. But when I run this like this, it's not going to work. Either you can add one more line that load module fastqc/version to be able to run fastqc, or you can use that singularity image that we already installed, fastqc HiSet2. HiSet2 is not there too, see? Oops. HiSet2. So they are not there. So that's why when you're running, you need to use the singularity image. We can show you how we are creating these images, how we are doing the installations, but the ones that we have already includes many of the software we are using in all these pipelines. So if they are already there, use it. If it is not, just let us know. We can create it for you, or we can show you how to create these kind of image files and send you some videos about them. And the options here, when you use any of them, in this case, I think we also have this image downloaded already into our cluster. You can either use like this. If you use like this, this means it is going to download this RNA-seq pipeline from our Docker Hub repository. And when you want to run the same pipeline somewhere else, running like this will help you a lot, because you don't need to copy the image file from one location to another. This pipeline is going to download it for you. Or if it is already in the cluster, our cluster, we already have it there. So you're going to save time from this download. Download usually takes, I don't know, 5 to 10 minutes. Is it, Onur, do you have any thought about how many minutes?
Yeah, 5, 10. Yeah.
Yeah. So run options here is important. So the spaces you are going to use has to be bind to this image. Otherwise, image cannot see your files, and then will give an error. So you have to write it. For example, if you're going to use project space or shared space or nearline, it has to be there. Your home is already bound, so you don't need to write home here. They have this functionality in the Singularity. But when you do this, it's ready to run now. So you can save and press start. So in the future, if you want to run this somewhere else, you can press this optional manual run. It's going to create a zip file, and then you can move that file to somewhere else. But make sure you enter here DolphinNext slash RNA-seq column 10. Otherwise, this is not going to pack this image file there, and it will give an error when you want to run. So these kind of things are important, I think. And then this is ready to run. I think overall thing is like this, that how you create the pipelines and start running. So if you follow all these things with your pipelines that you start creating in the future, more or less you're going to be successful. But if you're not, just let us know. There are some small tricks that maybe I'm not telling you, or I miss telling you, but you're going to catch it while you're doing these things yourself and learn faster. Okay, so I think I can accept your questions now.